This video is for 1.4 matter. First, let's talk about what matter is. Matter is anything that has mass and takes up space. So pretty much almost everything except for things like energy and stuff like that. First, let's talk about the three states of matter here. So 3 states of matter: solids, liquids, and gases. You've known about them since elementary school, even before that maybe, who knows. But you need to make sure that you know the properties of what makes something a solid, liquid, and gas. So solids have a fixed shape, means when you take it out of one container and put it into another, the shape does not change. Fixed volume, same thing. If I were to take a marble off the table and put it into a cup, does its volume and shape change? No, it is a solid. Liquids, the word variable means it can change. So a liquid, if you take it from one container and put it to another, it takes the shape of the container, meaning its shape changes. Fixed volume though, so if I have 10 milliliters here and I pour it into this one, it's still going to be 10 milliliters. Gases have variable shape and variable volume, so it all depends on the container that determines the shape and the volume of it. Here, this is showing you your solid, liquid, and gases. Solids stay that shape. Liquids, they go to the bottom of the container. Gases go everywhere inside of the container. That is why they take the shape and the volume of it. Okay. There are different types of matter, so that's what the next few slides are going to be about. Here you have what's called pure substances and mixtures. You've got to know the difference between these two terms. So pure substances also then break down even more into what's called elements and compounds. Mixtures break down even more into what's called homogeneous and heterogeneous. So the next two slides are going to break it down into what each of those little words stand for. Okay, the composition or the structure of a substance determines its matter type. So the structure determines what type of matter it is. Characteristics of pure substances. So in taking notes, you need to put pure substances and pretty much any key words that I highlight or underline. Okay, so pure substances have a fixed composition, meaning it's going to look the same every single time you look at it. Every little piece in it looks exactly the same. So in this picture, this is a pure substance because that looks exactly like that and so forth. This again is a pure substance because this looks exactly like that. Same thing here. Okay, they have distinct properties, meaning their properties are not going to change. Each little particle has the same properties. Cannot be separated into simpler substances by physical methods. So you can't go in and break that atom physically. Okay, can only change an identity by chemical methods. Okay, they can only be changed by chemical methods. Properties do not vary from one sample to another. So again, that will look exactly like that and so forth. So again, pure substances, these characteristics. Now to break it down even further, we're going to talk about elements and compounds. Elements. Okay, so again, in your notes, elements made up of one type of atom, cannot be broken down physically or chemically. Cannot be broken down physical or chemical. Some examples: oxygen, nitrogen, carbon, anything that's off the periodic table. Compounds is exactly what it means. Compound sentence in English means you're taking two things and cramming them together. Same exact thing. So compounds form two or more different elements come together. So this picture is showing you two or more coming together. You get this little cluster thing. Composition is identical. So again, that compound is going to look exactly the same. They can be separated chemically. So that's the difference between your elements and your compounds. Elements cannot be separated at all. Compounds can only be separated chemically. Properties of compounds are totally different than the elements that make them. So for example, NaCl, Na, sodium, if you throw it into a pond, it causes a mini explosion because it reacts with water. But yet when we put it with chlorine, we're able to eat it. Okay, so that's an example of that. Examples: water, carbon dioxide, sugar, salt, all kinds of stuff. Now let's talk about mixtures. Mixtures means exactly what You've always known it to be. It's when you combine things together, but you're going to combine them physically, okay? That's the difference between mixture and a compound, okay? Compounds are chemically mixed together. Mixtures are physically combined. All right, so properties of mixtures are related to its components. Composition varies. Composition varies from sample to sample. Can be separated physically. So you can boil things off, you can dissolve, you can physically remove a tomato from a salad kind of thing. Okay, there are two types of mixtures, homogeneous and heterogeneous. Homogeneous, heterogeneous. Homogeneous means same. Hetero means different. Okay, you're going to see these prefixes throughout your scientific life, okay? So homogeneous, same, hetero, different. So this is what it means. Homogeneous literally looks the same throughout. Heterogeneous, you can see the different particles, okay? Now let's specifically talk about each one. So homogeneous, some properties of it. They're known as solutions. Uniform distribution. Uniform, again, means same throughout. It looks the same throughout the entire thing. Examples, tea, perfume, air. Air is a mixture, a homogeneous mixture. It's not a compound, it is a homogeneous mixture. You can't see the different things that are in it. Okay. Hetero. Okay, heterogeneous mixture. Do not have uniform distribution. Do not have uniform. That means you can see the different parts. So like a salad, okay? Parts are often visible. Not always though, so you can't always see the different parts. So this is where we get what's called the Tyndall effect. Tyndall effect means that the light bounces off the particles. So you can't physically see the different particles going on. So if you shine a light through it and you can actually see the light going through it, then this is the Tyndall effect, okay? This is the Tyndall effect because you can see that light passing through it. And this is a solution. This is a homogeneous. You can't see that light going through it at all. So think about a laser pointer. When you have a laser pointer in class, okay, you can only see the red dot on the wall. You can't actually see the red laser going through the air because air is homogeneous. Now if I had a fog machine and I turned the fog machine on, you can actually see that ray of the laser. Again, that fog is a heterogeneous mixture. Okay, there are two types, suspension and the colloid. Examples of heterogeneous: salad, beach, that's supposed to say sand there, beach sand, oil and vinegar dressing. Anything that can be separated over time is going to be heterogeneous. Let me explain that, sorry. If it separates on its own, so this right here, if it separates on its own like oil and vinegar, it is heterogeneous. Like mud over time, the water's on top, the dirt goes to the bottom, heterogeneous. This is a picture sort of summarizing everything that we talked about, so I just want to go over it real quick. Distinguishing between elements, compounds, and mixtures through pictures. Okay, so these are single little balls here. Those are your atoms. Those circles represent your atoms. They are all by themselves. Single elements. Okay, single is an atom. Now here, if you look, they're paired together, but again, they look exactly the same. These pairs, these clusters, okay, the clusters are your molecules. They look the same the whole time. So this is a pure substance. Here, again, these clusters, they're the exact same every single time. So this is a pure substance. Here, you should be able to physically see. This one is different than all the other ones. You got single elements, you got some together, you got some different clusters. This is a mixture. You should be able to tell what a mixture is based on a picture or based on properties given to you.